And we can go to the next presentation, and we have two presenters this time. And are they here? Okay, so here we go, they are coming. So the next presentation will be done by Martin Wilbaum and Guillermo Fiorina. Martin and Guillermo are telematic engineering students at the University of Montevideo. They both work as associate professor at the University of Montevideo and are researchers of the study group 12 of the International Telecommunications Union regarding the performance, quality of service, and quality of experience. And they will do a presentation, half-half, I believe. So the stage is yours.
Bueno, buenas a todos. Somos Guillermo Fiorina y Martín Bilbaum y vamos.
Hello, we are Guillermo Fiorina and Martin Wilbaum. We're going to speak about this project, which is a platform to develop quality of experience in video conferencing services. Back in 2019, during the pandemic, there was a significant increase in the demand for video conferencing services. This demand continued over the following years. So the ITU, the International Telecommunications Unit, group number 2 of this ITU, proposed a project where the laboratories that you see in the screen also participated: China Mobile Communications, Wuhan University, Orange University of the Republic, and University of Montevideo, which is Guillermo and myself work. The expected outcomes of this project is to generate a database so that we can train a model to monitor and assess the user experience of telephony services. So we participated in a project. We began with a test bed and designing the parameters for the network. We then configured the test bed, we collected the data, we processed the data, and reached the stage at which we are now, which is the development and validation of this model. In order to generate this database, you consider 2 types of subjective tests: the subjective test that we called passive test and the active test. The passive tests are those where an individual receives audiovisual materials in one-directional communication and scores that the individual material based on the general quality in terms of the audio quality and the video quality. The active tests are those where 2 individuals in different rooms simulate a bidirectional real communication and then score this video call based on the same features, namely general audiovisual quality and audio quality and video quality, as well as other aspects. For example, the experience with delay, the freezing, and the effort required to interrupt the other speaker, and the lack of synchronization between the audio and the video.
It is important for the 2 tests, passive and active tests, they'll be used to generate one single model to monitor and evaluate the quality of experience in video conference, that is in bidirectional communication. So you may wonder why we use the subject passive test, because they provide a lot of advantages vis-a-vis the others, including flexibility to mimic real-life situations. It's not the same to have a video call at an office, a park, a stadium, and it is much easier to mimic this in the passive subjective tests, and they are much easier to execute initially because you don't need 2 subjects for tests, just one receiving the audiovisual material, but also the data collection is much more nimble. It's important Guillermo and I are working, processing the data associated to the active subjective test, and that is why we will emphasize them more during this session. However, it is important to also add the passive test to compare them against the active ones, because both types, active and passive, will provide us data for the database with which we are going to train the model. So on the screen, you can see a simple scheme of the passive subjective test, We have a pre-recorded material that gets coded, and we simulate the degradation, and we show it in different devices. It can be mobile phones, TVs, or computers to a subject that scores it in a different device. These audiovisual materials, as we see in the score, we can see that there may be video alone, audio alone, or both audio and video. And so here you see that the communication is bidirectional between two customers in different rooms. And this video call is goes through the big blue button device. That's what we used, an open source video call system that is very similar. And it is there that the network gets deteriorated, gets impaired.
Bueno, continuando entonces con lo que es
So going on with the active subjective test, this is in a controlled system, both for the equipment that was used by the participants and also the environment they were in. In this lab, we agreed on how the background would be, the complexity, the lighting, the surroundings, noises, and the monitor, the earphones, among other things. In addition, among other fixed parameters that we considered among the active and subjective tests, we have all those related to the setup of audio and video, including resolution, video codec for audio and video, the frame rate, and the packet loss pattern. So, and then we had the passive tests where, given the high flexibility they have, you can pre-record an audiovisual material and then to mimic their impairment with, or to take a video that is recorded in something and to then show it in a TV or a monitors. And although the active tests were not impaired, they remained fixed, but there are variables that should be considered in the final model. So now let's go on with the variable parameters that were considered in the active tests. They were considered as impairments in the network, and we started with a delay. We defined from RTT between the server and the clients with 3 different values. The jitter expressed as a percentage of delay, we considered 2 values, and the bandwidth, and we considered 3 different values. We also have packet loss, audio and video, considering 3 values, and asynchronism, that is the time between the difference of delay of audio and the video. This has 5 different values. It can be positive or negative depending on which delays which. If it's a video that delays the audio, or the other way around. In addition, when the tests were done in the laboratories, we seemed that out of simplicity it was easier to separate the conditions where there was synchronism and where there wasn't. The conditions with synchronism gave rise to 14 different cases, and without synchronism there were 49. So there were 43 different conditions that were assigned. 15 were assigned to each lab. Some of were unique, exclusive for that lab, and others were common with the rest of the labs. Just as an example, you can see on the screen the conditions that we had with Martín at the lab of University of Montevideo. And to your left, you can see the combination of parameters that we mentioned. To your right, you can see essentially the distribution, those that were just for us and those that were shared between all the labs. These common conditions are essential for several reasons, so that when we align all the databases, we can take them as common points of reference to form the global dataset that Martín was mentioning at the beginning. So now let me tell you the parameters, and we think it was interesting to tell you the criteria for selection, and we are going to focus on 2. Let me start by telling you the process of selection of the loss of packets, both audio and video. And we conducted preliminary tests with participants where, in addition to the blue button that Martin mentioned, some more massive video handlers such as Zoom, Meet, and Teams. And in these tests, we gradually raise the number of packets until the participants told us that they perceived it, or even that the level of loss bothered them. And it was surprising that, including for relatively high values, the participants didn't feel the impairment. And even when the packets were lost, these measures were close to 0%. So we investigated this, and we saw that most of the usual video handlers we disabled in the case of blue button, and we measured these parameters with no noise and clean, and we obtained these from there you have from 0.5% packet loss in the case of video. And then the asynchronism. For this, we use the recommendation 1359 of ITU that speaks of asynchronism in television services. What we saw initially was that there's an asymmetry in the threshold of acceptability by users. That is, the threshold is when is it that the user starts considering that what they lose is bothersome. At least 150 to 250 milliseconds. It's worse when the video delays the audio than the contrary. So, conducting preliminary tests, we see that the symmetry is preserved in the video conference, but with a higher acceptability threshold, that the participants tolerate better the video conferences, and we determined from 150 to 250 milliseconds as the threshold. And now let me tell you what indeed, how the values were gathered in an active test. So the participants were introduced as to what the research and the experiment were, and if they were not familiar with each other, if they didn't know each other, we introduced them. We gathered personal information and we started the test with two conditions in addition to the 15 that I told you, which for us are very important for the users to get used to the methodology and may get used to voting during the test. Having completed these two conditions, they started with the 15 conditions, and we as researchers, we send them randomly. Having completed each of these conditions, the users had to evaluate them, and finally, we considered the session was over.
Después de cada una de las condiciones,
in each of the conditions, the participants had to respond 7 questions. Each of the questions was associated to target characteristics that are these as follows. General quality of the teleconference, the quality of video, the desynchronization between audio and video, the experience with delay, the level of freezing in the video call, and the effort required to interrupt the other participant. So having collected all the data, we processed the data, started with cleaning the data. We had to eliminate the outliers. We used a criterion, contemplated the Pearson correlation and the response of the participants to each of the conditions. And we generated visualizations to better understand the data and draw some preliminary conclusions. On the screen, you have 5 graphs showing the general audiovisual quality of the call, the first of the target characteristics against all the rest of the target characteristic experience with delay, the quality of audio, the average overall quality of video, the freezing, and the effort required to interrupt the other participant. In this graph, here you see the average of the answers of all the participants for each condition. Each a pointer is associated to each of the conditions. I won't describe the details, but it's important to see that there's a high correlation between this characteristic, this primary, the general audiovisual quality, and each of the other target characteristics. So we can infer that we could have omitted some of the questions or some of the target characteristics in the active subjective test because it was rather tedious for the participants to vote, etc. So this was a problem if we wanted to have a lot of data, and you're going to see that that is a limitation as we develop the model. So after understanding this, we went on to analyze it, and we studied the impact of each of the variables analysis, packet losses, RTT, and delay in this primary target. And we saw that the two variables of analysis that were more relevant when voting for individual quality of the video called by the subjects were the loss of audio packets and video packets. And we saw that there was an asymmetry in the relevance of the bit rate of audio and video. For the participants, it was more important to lose bit rate in audio than video. So now let us tell you where we are today. That is the training and the validation of the model with which we are going to monitor the quality of the experience. Starting with a parametric approach. So we take as a reference the recommendation of ITU G1070, and we contemplate the possibility, and we conducted some tests to implement machine learning algorithms with these data sets of subjective test. To tell you the truth, we didn't have very good results in the implementation of the machine learning algorithms, or at least the metrics were not acceptable for us. And that is why that we, in the future, we want to implement these machine learning algorithms to estimate and monitor the quality of the experience, but with larger data sets of streaming or video conferences. So this was all. Thank you for your time, for your attention. Guillermo and I are talking, but there's a very large team. We want to thank all the labs that were part of the project, and essentially those that are closer to us in Uruguay, Rafael, Jose, Alejandra. And obviously, if you have any questions, it's more than welcome.
Thank you very much. Thank you very much for your... Immediately.
Muchas gracias. Tenemos una pregunta aquí. Very good job. My question is, when the subjects of the test were seeing the video, did you tell them how many packets were being lost? And the question is, did you use something that the pharmaceutical industry uses, a placebo, saying, now I went up from 30 to 50. Did that make a difference? Well, first of all, thank you for your question. It's very interesting. No, we never considered the placebo effect when we conducted these tests.
We didn't tell them, well, in order to avoid any type of bias, we realized that when we carried out tests to check that everything was working properly, if I sent Martin a condition that wasn't working well and he did the assessment, he already knew more or less that although the participants didn't have such an academic or technical background, they could carry out include some kind of bias, and we prefer to avoid that. In order to avoid biases regarding the order of the conditions that we have submitted, we sent these randomly. Thank you. Thank you for your presentation. I have a concern. You spoke about how you were measuring the problems when streaming a video conference. I'd like you to tell us what you could do to improve or remove those problems that you mentioned, the delay, the freezing. What do we do there? Do we increase the bandwidth? Do we prioritize the packets? What would you suggest so that the video conference is more stable? Those of us who provide the services, which are very often critical, Please, could you let us know? Once again, thank you very much for your question. As Martin was explaining, we are at the stage that we finished data processing. We're now focusing on the model development. Let us remember that this is based on being able to measure and determine the user experience of the video calls. Ideally, the video calls should be based on this recommendation and the model that we're trying to set up so that you can then determine this. This is not so much in order, well, it could be used to see which are the most relevant or less relevant parameters to take into account, but that would not be the case to see what changes should be carried out. I would like to add a comment. We could see during data processing that the packet loss, the idea of the recommendation is to give you an idea of which are the most relevant parameters and which have to be highlighted when monitoring the video call. We saw, for example, that packet loss is very clearly the parameter that most affects users when scoring the video quality. And what we are studying is considering these conditions to provide a diagnosis on how users would score that video call. And like Guillermo was saying, the concept we have is establishing the order of relevance of the different parameters, but we still haven't studied how to provide certainty and how to ensure that these parameters yield good values in the video conference.
Thank you very much for your presentation. It was great.